Let's learn how to calculate a theoretical yield. It's not that hard. Roll the graphic. Hi, I'm Paul. This is Science That Sticks. Welcome back. In this session, I'm going to talk through a series of steps that enable you to calculate a yield given some information. It's not that difficult to do. In fact, actually, once you learn the process, it becomes easy. And if you learn this process, then doing a titration calculation is also easy. So let's look at the question. Calculate the mass of MgO produced when 7 grams of magnesium is reacted in excess oxygen. The first job that you need to do is have a balanced chemical equation for the combustion of magnesium in oxygen to form magnesium oxide. I really like using this as a balancing equation, but also for lots of different ways of using this reaction in examples. So I know that I'm going to need 2 MgO, 1 O2, and I'm going to make 2 MgO. I'm asked about how much of this I can make when I've got 7 grams of magnesium. The fact that it's 2 here and there's a 2 there simply means that whatever molecules of this I have, or the mass of this, or no, actually not the mass, the number of moles of this I've got, I'm going to have the same number of moles of product. So that's an easy concept. Firstly, I need to find out how many moles are in 7 grams of magnesium. Easy enough. So the moles is equal to the mass, which is 7 grams, divided by the relative atomic mass, which happens to be 24. 7 divided by 24 happens to be 0.29. It goes on a bit, but I'm going to leave it at 0.29. The 2 at the front is irrelevant in terms of this calculation. And the same is true there. So this is the number of moles of magnesium that is present in 7 grams, which means there's going to be 0.29 moles of magnesium oxide. Easy enough. So the moles of magnesium oxide happens to be this if this is completely burned in excess oxygen. Now we need to find the mass of this. Well, the mass is equal to the moles times by the relative formula mass. In this case, MgO. So I've got 0.29, and I'm going to multiply it by 24 add 16, because the relative atomic mass of magnesium is 24 and the relative atomic mass of oxygen is 16. 16 add 24 is 40. If we multiply the 2 together, we end up with 11.6 grams. That would be our theoretical yield. Now, let's go through those steps just one last time. The first thing is you've got the question. Calculate the mass of magnesium oxide produced when 7 grams of magnesium is reacted in excess oxygen. The excess means you've got more than you need. You write a balanced equation. You normally are given this in a GCSE exam, but if you're not, make sure that you have the balanced chemical equation. You then calculate the number of moles of the reactant that you have. 7 grams divided by 24, because it's got a relative atomic mass of 24. In this case, it comes out to be 0.29. Because it's a 2 to 2 ratio, the number of moles of this I have is going to be the same as the number of moles of that, the magnesium oxide. I then need to calculate the relative formula mass of magnesium oxide. This is 24, this is 16, and the 2 make 40. That's 40 grams per mole. This 40 is going to find its way right down to here, because I need to rearrange the equation. Moles equals mass divided by RFM. And it's rearranged to mass equals moles times RFM. So I multiply the 2 together and I end up with 11.6 grams. That's it. You can apply this to you can apply this to all theoretical yield questions. Go and do it, go find some, go practice or make your own up. Until next time, everyone, stay cool. Bye for now.